For our prehistoric ancestors, recognizing patterns was a key to survival. As they made their way in the world, they saw patterns in the landscape, patterns in the weather, and patterns in the behavior of birds and animals. And when they looked up at the night sky, they saw patterns too. What they found is that the stars aren't spread evenly across the sky. Many of the brightest stars seem to be grouped in a way that naturally draws the eye. And as Earth turns, these stars seem to move together, reinforcing the impression that they are related. By playing connect the dots with these groups of stars, ancient people transformed them into pictures, often of mythical creatures and characters from great legends. We know them as the constellations.
The constellations are still with us today, and they're a reminder of our ancestors' enduring fascination with the stars. But there can be even more to these ancient star pictures than meets the eye. Sometimes, stars we see together in the sky really are related.
A case in point is one of the most familiar star patterns of them all, the Big Dipper. The name reflects the way these 7 stars are arranged in the sky. Together, they resemble the outline of a pot with a handle. There are other ways of seeing it, though. In some folk traditions, it's not the dipper, but the wagon or the plow. And for the ancient Greeks and Romans, it was the Great Bear, Ursa Major in Latin, the official name astronomers still use for this constellation. To modern eyes, turning these stars into the image of a bear seems a bit of a stretch. The bear is usually portrayed with the handle of the Big Dipper as its long tail, even though real bears don't have long tails. But the bear connection makes more sense when we consider that the ancient Greeks called this constellation Arctos, a name that gives us the word Arctic. Arctos, or Ursa Major, may be our link to a much older tradition of bear legends. One that stretches back to the end of the last ice age, when the inhabitants of Europe and Asia were nomads wandering in a great northern wilderness. Perhaps they were the ones who first connected the most powerful animal in their world to the most prominent star pattern in their sky. So it seems fitting that in more recent times, astronomers have learned that the stars of the Big Dipper are themselves a wandering band of stellar nomads. This became clear in 1869, when British astronomer Richard Proctor noticed that 5 out of the 7 main stars in the Dipper are all moving through space at the same speed in the same direction, like airplanes flying in formation. Proctor had discovered what we now call the Ursa Major Association. Half a billion years ago, these stars formed together in a cloud of gas and dust. Today, we can find the same kind of raw material adrift in other regions of our galaxy. One of the nearest is called the Taurus Molecular Cloud. In this gorgeous view from the European Southern Observatory, we can see sections of the cloud wafting across the starry background. Over time, gravity can concentrate dark clouds like this, turning them into clusters of brilliant young stars. But even though they are siblings, such stars are unlikely to stay together forever. Instead, star clusters tend to spread apart as they drift through the galaxy. And that means the Ursa Major group may be a lot bigger than it seems, extending well beyond the 5 Big Dipper stars that Proctor once connected. Even Sirius, the brightest star in the night sky, was once thought to be a member of this group. More recent data now suggest it's too young to have formed along with the Ursa Major Association. In 2003, a detailed survey based on data from the Hipparcos satellite found that 59 stars are likely members. These stars are scattered across 30 light-years of space, with the center of the group located about 80 light-years from our solar system. In galactic terms, this is remarkably close. It's purely by chance that our existence happens to coincide with the moment when Earth is on the outskirts of this passing system. Millions of years from now, those stars will have moved on, and the Big Dipper will be no more. But astronomers have discovered that Ursa Major is not the only constellation with a hidden connection among its stars. Throughout history, when adventurers and traders headed east or west to distant lands, they knew they were bringing their constellations with them. As Earth turns, places on the globe that are at similar latitudes, like Europe, Asia, and North America, will see the same stars. But those who travel south experience something very different. Earth doesn't turn north to south, so there are stars and constellations that can never be seen from northern latitudes. It's here in the south that we find Centaurus. It's a sprawling constellation that the ancient Greeks pictured as a spear-wielding centaur, the imaginary creature that is half man, half horse. Like Ursa Major, the Great Bear, the outline of the centaur may not seem obvious to modern eyes. But there's no mistaking the 2 brightest stars in this constellation, known as Alpha and Beta Centauri. Together, they point to another group of 4 stars, which the ancients also imagined as part of the centaur. Today, we identify this group as a separate constellation, and it's one of the most famous, the Southern Cross.
Whether it's one constellation or 2, the combination of the Southern Cross with Alpha and Beta Centauri forms the dominant star pattern of the Southern Hemisphere. But how did the ancient Greek astronomers know about these stars, which can't even be seen from Greece?
The answer is precession. It's a term that describes a gradual change in the direction of Earth's axis as our planet slowly swivels around like a big gyroscope in space. Because of precession, the stars of Centaurus and the Southern Cross have shifted over the centuries. Once, long ago, they were visible from Europe. Now they've become, for the south, what the Big Dipper is in the north. Many of the stars in Centaurus and the Southern Cross are moving through space with a similar speed and direction. But this association is far younger than the Ursa Major group, and it contains stars that are much brighter. Many are blue giant stars, thousands of times more luminous than our Sun. Blue stars burn out quickly. The hottest ones only last a few million years, a tiny fraction of our Sun's age. As they use up their fuel, blue stars eventually expand and change into red supergiants. This has already happened to the brightest member of the group, the brilliant red star Antares. Antares is part of Scorpius, a different constellation, but its motion connects it to the stars of the Centaur and the Cross. Collectively, they are the Scorpius-Centaurus Association. The ultimate fate of these bright stars is to die in spectacular fashion. As each one runs short of fuel, its core will collapse, triggering a supernova. A violent stellar explosion that rips the star apart. The explosion produces a blast of energized gas that spreads out into the surrounding space for hundreds of light years. This, too, has already happened in the Scorpius-Centaurus Association. The entire group, including most of the stars of the Southern Cross, sit inside a bubble about 400 light years across. Astronomers suspect the bubble was formed by one or more of the association's stars going supernova during the past 15 million years. The bubble can't be seen with an ordinary telescope, but in this map of the Milky Way in radio waves, part of it shows up as a giant loop in the foreground. Astronomers call it Loop 1. Our own solar system lies just outside Loop 1 in another smaller bubble. This local bubble may also have been caused by one or more supernovas, perhaps when the Scorpius-Centaurus Association was closer to Earth than it is now. This idea was strengthened in 2004 when researchers discovered a rare isotope called iron-60 in sediment deposited at the bottom of the Pacific Ocean. Iron-60 is produced in supernova explosions. This suggests that sometime in the last 3 million years, Earth was in close proximity to a supernova. Such an event may have had serious consequences for life. One group of researchers has even speculated that a major extinction of corals and other marine life about 2.5 million years ago was caused by a supernova blasting Earth's atmosphere with radiation, temporarily destroying the ozone layer. So far, this idea remains speculative, and there are reasons to be skeptical. Astronomers have calculated that a supernova would have to be within 26 light years of Earth to cause such severe damage to our planet. While that's not impossible, a supernova going off so close to us so recently would be quite a coincidence. What we do know is that our planet did change at that time, with some creatures dying out and some new groups appearing, including the first members of our own genus, Homo. Whether our pre-human ancestors were somehow affected by a nearby supernova remains an open question. But when we look to Centaurus and the Southern Cross, we're reminded that hidden connections between the stars may sometimes include us. Winter in the northern hemisphere is the time when many of the brightest stars can be seen high overhead. Among them are Castor and Pollux. These stars, almost identical in brightness, are the Gemini twins. They're part of a constellation that depicts two brothers in the heavens. But these stars are not related. At just 34 light-years from Earth, Pollux is both closer and older than Castor, which is 50 light-years away. They are siblings in name only. It's the same story with another well-known winter constellation, Cassiopeia, named after a mythical queen. The 5 brightest stars in Cassiopeia form a W pattern that's easy to spot in the northern sky. But in this case, the grouping is pure coincidence. The stars in the W are spread out along a line of sight that ranges from about 50 to over 500 light-years away. They too are not related. Nevertheless, most stars must have relatives somewhere because stars tend to form in clusters within vast clouds of dust and gas. If we look towards the stars of the Southern Cross, we can see a recent example. Near the Cross, but 6,000 light-years further away, lies one of the greatest treasures of the southern sky. In the 19th century, astronomer John Herschel called this the Jewel Box star cluster. With its concentration of hot blue stars and bright red giants, the cluster reminded Herschel of a casket full of precious stones. Today, astronomers estimate the cluster contains about 100 stars that formed around 12 million years ago. As the cluster ages, the brightest stars will quickly exhaust their fuel and burn out, in some cases going supernova, like the stars of the Scorpius-Centaurus association. Those stars that remain will continue to travel together, like the Ursa Major group. But over billions of years, they're destined to drift apart and lose each other among the stars of the Milky Way. Our own Sun is one such star. Now 4.5 billion years old, it too must have relatives somewhere out there in the galaxy. Some of those sibling stars could have planets and even life. Since life here is based on the chemical ingredients that went into forming the Sun, it would be fascinating to see what happened to the same ingredients elsewhere. But could we find the Sun's long-lost relatives? Are they hidden somewhere among the familiar constellations? One approach to answering these questions is to look at the nearest stars and see if any have strong similarities to our Sun. The nearest star of all is Alpha Centauri. Although it appears to the eye as a single point of light, Alpha Centauri is actually a multiple system made up of 3 stars in orbit around each other. The smallest is a red dwarf star, known as Proxima Centauri, because it's also the closest of the 3. The entire system is only 4.3 light-years from us. That's still thousands of times further than the most distant planet in our solar system, but for a star, it's very, very close. In fact, it's so close that Alpha Centauri can't be a member of the Scorpius-Centaurus association. It just happens to be in the foreground when we look toward those stars. Similarly, someone living on a planet in the Alpha Centauri system would see our Sun as part of the constellation Cassiopeia, giving the W an extra zigzag. But even if such a planet exists, we already know that any creatures living there cannot be our galactic cousins. The Alpha Centauri system is older than the Sun, and it's moving on its own separate course. After its closest approach, about 27,000 years from now, the system will gradually start to pull away from us, and it will eventually fade into the starry background. Meanwhile, the search for our sun's true siblings continues. In 2013, astronomers conducted a careful study of 30 stars known to have ages, compositions, and motions similar to the Sun. After a close examination, only one of the 30 qualified as a possible true sibling to the Sun. It lies just over 100 light-years away in the constellation Hercules. It doesn't have a name, just a catalog number, HD 162826. But this one candidate sibling could soon be joined by others. In December 2013, Europe launched the Gaia mission. It's a space telescope that will help construct a 3D catalog of nearly 1 billion stars, roughly 1% of the Milky Way's total stellar population. As never before, Gaia will reveal precisely where all the stars are around us and show us how they're moving. In doing so, it will reveal which stars are truly associated with one another, including those that might have a connection to our Sun.
Long ago, our ancestors looked for patterns in the stars, and they invented the constellations, groups of stars that have a story to tell. Now Gaia is giving us a more sophisticated way of observing the stars, but we're still looking for patterns.
What we find will reveal the unseen relationships among the stars around us and give us a new set of stories. It may even give us a story that includes us. The story of a great family of stars that formed together in a cloud, spread out into the galaxy, and along the way brought the galaxy to life. By playing connect the dots with these groups of stars, ancient people transformed them into pictures, often of mythical creatures and characters from great legends. We know them as the constellations.
The constellations are still with us today, and they're a reminder of our ancestors' enduring fascination with the stars. But there can be even more to these ancient star pictures than meets the eye. Sometimes, stars we see together in the sky really are related.
A case in point is one of the most familiar star patterns of them all, survival. As they made their way in the world, they saw patterns in the landscape, patterns in the weather, and patterns in the behavior of birds and animals. And when they looked up at the night sky, they saw patterns too. What they found is that the stars aren't spread evenly across the sky. Many of the brightest stars seem to be grouped in a way that naturally draws the eye. And as Earth turns, these stars seem to move together, reinforcing the impression that they are related. For our prehistoric ancestors, recognizing patterns was a key to survival.